So I'm going to look at, this is CC3 2.1.6, section 2.1.6, number 2-59. Okay, so we've got a situation where we're have our rectangles. Let me just read this and we'll go from there. Cairo wants to create a graph that represents the heights and bases of all rectangles that have an area of 36 square units. He started by drawing the rectangles A, B, C, and D at the right. Examine the dimensions, length and width of each rectangle. So if I look, I did go ahead and ahead of time here count the squares and put in my dimensions. So this one is a 9 by, and that's a 4, 9 by 4. This one is an 8 by 4.5. So that length right there is 4.5. This is a 6 by 6. So C is a 6 by 6 and D is a 3 by 12. So those are the dimensions of these rectangles. And each of those all have area of 36, right? If I multiply 9 times 4, 36, 8 times 4.5, 36, 6 times 6, 36, 3 times 12, 36. Okay, so part A says copy the graph below on graph paper. So this is, you need to put this on your paper, your actual binder paper or a piece of graph paper. Then match the letter of each rectangle above with the point on the graph. Which point is not matched? So first of all, if I look at A, triangle A is a 9 by 4. Well, actually, we have it actually, the base is the X, and the height is the Y, right? So the first letter or the first number for this rectangle would actually be 4. So 4 comma 9. 4 comma 9 is right there. So A is 2, right? So A is 2. So we can just do that. A is 2. And then rectangle B is the base is 8. The height is 4.5. So base is 8. Height is 4.5, which looks like it's right there. So that is B. Okay. Oops. B. So B is 4. Okay. And then C is a 6 by 6. So if I go 6 over 6 on the X, up 6 on the Y, that looks like 3. So C is matched with 3. And then D, so D here is a 3 by 12. So base is 3, which is right around here and up at 12. So rectangle D, is 1. So D goes with 1. All right. So then it says that which point is not matched. So this point here, 0.5, okay, 0.5 is not matched. And what is that point? 0.5 is not matched. 0.5 is the X value is 6 and the Y value is 4. So it's a 6 comma 4, right? So 0.5 is not matched and it's a 6 comma 4. That's what it asks. So let's go on to part B. Part B then says, make some room here. Part B says, what are the base, height, and area for the unmatched point? So the base, height, and area. So the base, remember the base is this direction. The base is 6. The height is the Y. So the height goes up and it stops there at 4. So the height is 4. And then the area, then if the base is 6, the height is 4, the area is 24, 6 times 4, right? So that's the area. So why should the unmatched point not be on Cairo's graph? Well, because Cairo's graph represents rectangles with an area of 36, and that has an area of 24, right? So that's why. So it's not got the right area. So looking at find the dimensions, the part D, find the dimensions of 3 more rectangles that have areas of 36 square units. So 3 more, okay. At least one of your examples should have dimensions that are not integers. What does that mean, not integers? Not integers are is a fraction or decimal. Okay, so we can look at that. Place a new point on the graph for each of the rectangles. So I need 3 more that are not listed. So 3 more that are not listed. Let's see. So if I got a 4 by 9, 8 by 4.5, 3. Oh, let's go with a rectangle that is a base of 18 and a height of 2. Right? A base of 18 and a height of 2, that has an area of 36. And then a base of, I'm going to do a couple that are non-integers so you see that example. So if I know the area, here's how I find a fraction or decimal. If I know the area is equal to 36, I just pick a number. So in other words, let me just pick a number, let's say 10. Let's say the base is 10. If the base is 10, what would be the height? So what has to be true in this case? 10 times something equals 36. Well, how do you solve for that something? Well, do the reverse. That something would be 36 divided by 10, right? The opposite operation of times is division. And if I take 36 divided by 10, I can write it as a decimal, which is 3.6. Or I could write it as a fraction, which is 36 over 10. So you could say the length here is, or the height is 33.6. Or I could say it's 36 over 10. Or if I want to even simplify that further, that would be 18 over 5. So I can have a rectangle that has a fractional value or a decimal value. So we'll pick one more. So there's an example of one. So this would be a 3.6 by 10. And then how do I graph that? Just, you're going to graph each of these. But say I graph this one, the 3.6 by 10. The base is 10. The height is 3.6. So the base is 10. And the height is 3.6, which looks like right about there. Right? That would be, let's call this rectangle E. So rectangle E would be right here if I went ahead and graphed it. So let's do one more that's a non-integer. And again, I just pick any value. I'm going to pick, let's go with, I did 10. How about 5? So if I pick a base of 5, what is my height? Right? So again, 5 times something equals 36. So the opposite operation would be to divide both sides by 5. So this value here, this h, we'll call it h for height. The variable h would be what? H is equal to, h is equal to 36/5. Or we can put that in a mixed number and call that 7 1/5. Or we can actually put it in a decimal and do the decimal equivalent, which would be 7.2. Right? So either way, you can have a decimal, you can have a fraction. So if my base is 5, my height is 7 1/5 or 7.2. So one more, let's graph this one. We'll call this F. So I'm going to take F, which I said was 5 by 7.2. So the base is 5, which would be right about here. And 7.2, which looks like it's going to be right about there. And that would be F for me. All right. Okay. I hope that helped.